Hello class, today we're going to go over operations with polynomials. So we're going to be adding, subtracting, and multiplying polynomials. But before we go ahead and do that, let's look at an example. Shelley has narrowed her choice for which college to attend. She is most interested in Southwest Minnesota State University, where the current year's tuition is $3,872. Shelley assumes that tuition will increase at a rate of 6% per year. Express the tuition after X years as a polynomial. Okay, so what I would do is think if it is the first year or year 0, okay, she's going to pay $3,872. Okay, but every year after that, it's going to increase by 6%. So it would be my tuition, which is $3,872, times 6%. 6% as a decimal is 0.06, so times it by 0.06, and we'll let that be by x, the years. Okay, so here will be my polynomial. This is the original tuition for year 1, the first year, okay, and then every year after I'd add on that interest. So my polynomial would be 3,872 plus, if you take 3,872 times 0.06, you get $232.32. Okay, so that means basically every year it's going to increase by that much. And typically we write polynomials in standard form, so it means the variable with the highest exponent all the way down to the constant. So if I did that, we'd be $232.32 x plus 3,872. This would be my polynomial. Okay, so the degree of a polynomial, we need to talk about what that is. Okay, it's the value of the largest exponent, or the sum of a monomial in the polynomial. Okay, so you have room in a box, so make sure you write that down. And then just one thing to talk about, a monomial. X is a monomial. 2x squared is a monomial. So mono means one, so it's just one variable with maybe a term in front. Okay, and then adding a bunch of monomials together will get you a polynomial. Okay, so here's an example. I want to state what the degree is. Okay, so it is the largest exponent or the sum of the exponents. So the degree in this one, well, there is only one exponent, so this is a 5th degree polynomial. The next one I go ahead and look at, the degree for this one. Okay, well, this has a degree of 3. This exponent's 2, and this is really x to the 0. Sorry, we're using a in this problem, so it'd be a to the 0. So the one that has the highest is a to the 3rd, so my degree is 3. Okay. See, if I look at that one, I'm going to have to go ahead and sum. 7 plus 4 will give me 11, and this is 2x to the 1st. So which one is the highest? The sum of these two. So the degree is 11. Let's look at a few more examples to identify the degree. Number 1, once again, I'm going to add them. 3 plus 5 is 8, and this is 4. So which one has the highest? The 8. The addition of those two, so the degree is 8. Same thing here. This is a 5, this is 1, so this would be 6. 4 plus 3 is 7. 1 plus 1 is 2. So this is the highest sum, so my degree is 7. The next thing we're going to go ahead and look at is the operations with polynomials. Okay. When you are adding 2 polynomials, make sure you just combine your like terms. Okay. Subtracting, I want you to add the opposite, okay, or distribute the negative sign and then combine like terms. And then multiplication, distribute, then combine like terms. Okay, so let's go ahead and just look at some examples. Example 3, biggest thing to do is identify what you are doing, and you are doing subtraction here. So what I would recommend doing is distributing this negative. Okay, so I'm rewriting this first one. Minus x squared minus 4x plus 2. Okay. Now all you need to do is combine like terms. 3x squared, negative x squared, so I get 2x squared. Now I have negative 2x and negative 4x, so negative 6x. And then lastly, I have 3 plus 2, so plus 5. So 2x squared minus 6x plus 5. That is what you get when you subtract the two polynomials from example 3. Example 4. I would look once again what operation is occurring. This is addition. So all you need to do with addition is just combine your like terms. So I have 5x squared and negative 3x squared, which gives me 2x squared. Negative 4x plus x gives me negative 3x. And 1 and negative 3, when I add those together, I get negative 2. So I get 2x squared minus 3x minus 2. Example 5. Once again, look what operation is occurring. This is subtraction. So once again, I want to go ahead and distribute that negative sign to everything and then combine like terms. So I have negative x squared minus 3x plus 4 minus x squared minus 2x minus 5. Now I'm going to combine my like terms. Negative x squared minus x squared, so I get negative 2x squared. Okay. Negative 3x minus 2x, so minus 5x. And then 4 minus 5 gives me negative 1. So my polynomial is negative 2x squared minus 5x minus 1. And lastly, on the front side of our notes, we got number 6. We are once again doing addition. So all we need to do is combine our like terms. 3x squared, it's the only one, so 3x squared. Then I would go on to my x. Okay, I have negative x, so just minus x. And then lastly, my constant terms are my numbers. I got negative 6 plus 1, so minus 5. Okay. Before we move on to the back side, if you have any questions on the front side, be sure to write them down. Make sure to ask me in class. Okay, let's try some more. Number 7. This time we are multiplying. So what we need to do is we need to go ahead and distribute that 2x to everything. So 2 times 7 is 14. X times x squared, when I add exponents, I get x to the third. 2x times negative 3x, well, it's going to be negative. 2 times 3 is 6. X times x is x squared. And 2x times 5, so plus 10x. And then I look, do I need to combine any like terms? No, so that will be my answer. Example 8. Okay, same idea as 7. So I'm going to go ahead and distribute the negative 2a. So I have negative 2 times negative 3, so 6. A times a squared is a to the third. Negative 2 times negative 11, so plus 22. A times a is a squared. And then negative 2a times 20. Well, negative 2 times 20 is negative 40. And a. Once again, I look, do I need to combine any like terms? Already done, so that is my solution. Example 9. I look what's happening in between these two polynomials. They are being multiplied, so you just need to distribute a whole bunch of times. So the first one I would do is I would take n squared times n, which gives me n to the third. Then I take n squared times 4, so plus 4n squared. Now I would take 6n times n, so that gives me plus 6n squared. 6n times 4 plus 24n. Now I move on. I have negative 2 times n, so minus 2n. And then negative 2 times 4, so minus 8. Now I just need to combine my like terms. I have n to the third. That's the only one. Now I look. I have n squared. So 4n squared plus 6n squared gives me 10n squared. Then I have 24n minus 2n, so plus 22n. And then lastly, my minus 8. And I make sure I have everything combined. I do, so that is my solution from multiplying those two polynomials. Okay, and example 10. Same idea. We are multiplying the two, so I just need to distribute everything. 2x squared times 3x will give me 6x to the third. 2x squared times negative 1 is negative 2x squared. Negative 4x times 3x gives me negative 12x squared. Negative 4x times negative 1 gives me plus 4x. Then I go ahead, I have 5 times 3x, so plus 15x. And then 5 times negative 1, so negative 5. Then I combine my like terms. I have 6x to the third. That is the only one that I have. So 6x to the third. I have negative 2x squared minus 12x squared, so negative 14x squared. Then I have 4x plus 15x, so plus 19x. And then lastly, my constant, minus 5. Make sure I have everything combined, and that would be my solution. Okay. So those are just the basic operations, adding, subtracting, and multiplying polynomials. Now let's just go ahead and look at some word problems. Number 11. Suppose R and W represent two genes that a plant can inherit from its parents. The terms of the expansion of R plus W squared represent the possible pairing of the genes in the offspring. Write R plus W squared as a polynomial. So R plus W squared. Okay. If it is squared, what that means is it's really R plus W times R plus W. So we just need to go ahead and put it as a polynomial. So we are multiplying. So same thing as before. I would take R times R to get R squared. R times W, so plus RW. Then I would go ahead, W times R, so plus RW. And then lastly, W times W, so plus W squared. Lastly, I would combine my like terms. So I would get R squared plus 2RW plus W squared. This would be my polynomial. Number 12, the volume of a rectangular prism is given by the product of length times width and height. Okay, so volume. Samantha has a rectangular prism that has a length of b squared, a width of a, and a height of AB plus C. What is the volume of Samantha's rectangular prism? So volume is equal to all of these things multiplied together. First thing I would do is b squared times a. Usually write it in alphabetical order, so it's a times b squared. And then I have a times b plus c. Then I would go ahead and distribute all of this. So take this times ab. So I would have a times a would give me a squared. B squared times b would give me b to the third. Plus, and I'm going to go ahead and distribute it to here, I would still have a b squared times c. And that would be my volume, okay, in simplified form because I cannot combine any of those. The only thing I should do is label, and it would be units, and volume is cubed. So that will do it for the notes for section 6.2 today. Please make sure if you have any questions, write them down, come and ask me in class. Otherwise, have a great day.